In a small village in southern India, a young clerk with no formal training in advanced mathematics wrote letters containing mathematical formulas so profound and mysterious that they would baffle the greatest minds at Cambridge University, equations that seemed to appear in his dreams fully formed, theorems that would take decades for professional mathematicians to prove or even understand. Yet this self-taught genius would die in poverty at age 32, leaving behind notebooks filled with discoveries that continue to revolutionize fields from computer science to string theory a century after his death. His story represents one of the most extraordinary and tragic instances of pure genius emerging from complete obscurity, only to be cut short just as the world began to recognize the magnitude of his contributions. This is the remarkable tale of Srinivasa Ramanujan, the man who claimed a Hindu goddess whispered mathematical truths to him in his sleep, whose intuitive understanding of infinite series and number theory defied all conventional paths to mathematical knowledge, and whose brief collaboration with English mathematician G. H. Hardy produced some of the most beautiful and significant results in the history of mathematics. Born on December 22, 1887, in Erode, Tamil Nadu, Ramanujan grew up in Kumbakonam, a temple town known for its religious scholarship but isolated from centers of scientific learning. His family belonged to the Brahmin caste but lived in relative poverty, his father working as a clerk in a cloth merchant's shop earning barely 20 rupees per month. From his earliest years, Ramanujan demonstrated an uncanny ability with numbers, asking questions about mathematics that his teachers could not answer by the time he was 10 years old. At age 11, he had exhausted the mathematical knowledge of 2 college students who lodged at his home, mastering trigonometry and developing his own methods for solving equations that even university students struggled with. The trajectory of his life changed forever when at age 15, he obtained a copy of George Shoebridge Carr's book, a synopsis of elementary results in pure and applied mathematics, from the local library. This dense volume contained over 5,000 mathematical theorems presented with minimal proof or explanation, merely stating results without showing how they were derived. For most students, such a book would be nearly incomprehensible, but for Ramanujan, it became a revelation that opened doors to the infinite landscape of mathematical truth. He began working through every theorem, attempting to prove each one independently, filling slate boards with his calculations because paper was too expensive for his family to afford. He would copy his final results into notebooks, erasing and reusing his slate work countless times, developing an extraordinarily compressed notation style that would later frustrate mathematicians trying to follow his reasoning. Ramanujan's genius created unexpected problems as he progressed through his education. He won a scholarship to Government College in Kumbakonam based on his exceptional mathematical abilities, but his obsession with mathematics caused him to neglect all other subjects completely. He failed his examinations in physiology, English, and Sanskrit, losing his scholarship and devastating his family who had hoped education would lift them from poverty. He attempted to continue at Pahiyappa's College in Madras, but again failed his examinations because he studied only mathematics while ignoring required curriculum in other subjects. By age 20, he had no degree, no formal qualification, and no prospects, yet his notebooks were filling with mathematical discoveries that would eventually be recognized as revolutionary breakthroughs. to support himself and later his young wife Janaki, whom he married in an arranged ceremony when she was only 10 years old. Ramanujan took a clerk position at the Madras Port Trust, earning 30 rupees per month. His supervisor, a civil engineer named S. Narayana Iyer, recognized something extraordinary in the young clerk who covered every available surface with mathematical calculations during breaks and lunch hours. Iyer introduced Ramanujan to other mathematicians in Madras, including Ramachandra Rao, who was so astounded by Ramanujan's work that he offered to support him financially so he could focus entirely on mathematics. In 1913, encouraged by Indian mathematicians who recognized they were witnessing genius beyond their ability to fully evaluate, Ramanujan wrote letters to 3 prominent professors at Cambridge University in England. 2 never replied, likely dismissing the strange formulas from an unknown Indian clerk as the work of a crank. The 3rd letter reached G. H. Hardy, one of the leading pure mathematicians of the era, who nearly made the same mistake. Hardy's initial reaction upon seeing pages filled with bizarre theorems stated without proof was that this must be fraud or delusion, yet something made him pause and examine the formulas more carefully. If these stories of extraordinary minds emerging from impossible circumstances to reshape human knowledge inspire you, consider subscribing to Hidden Minds and activating the notification bell to discover more hidden geniuses whose brilliance transcended every barrier society placed before them. As Hardy studied the mathematical expressions Ramanujan had sent, he experienced what he later described as one of the most remarkable moments of his career. Some formulas he recognized as known results, proving the sender had genuine mathematical knowledge, but others were entirely new and deeply surprising. Most significantly, several theorems were so strange and profound that Hardy knew they must be true, because no one would have the imagination to invent them unless they had actually discovered them. Hardy showed the letter to his collaborator J. E. Littlewood, and they spent hours analyzing the pages, concluding that they were looking at work from a mathematician of the highest class, completely self-taught and working in total isolation from the mathematical community. Hardy immediately wrote back, encouraging Ramanujan and eventually arranging for him to come to Cambridge, though this created enormous personal conflict for Ramanujan. As an orthodox Brahmin, traveling overseas was forbidden by his religious traditions, and his mother violently opposed the idea. The journey finally became possible in 1914 when Ramanujan had a vision that the family goddess Namagiri appeared to him and gave her blessing for the voyage. He sailed for England, leaving behind his wife, his mother, and the only world he had ever known, traveling to a land whose culture, climate, and food would prove devastating to his health. The collaboration between Hardy and Ramanujan at Cambridge produced some of the most significant mathematical discoveries of the 20th century. Hardy was rigorous, trained in formal proof, skeptical and demanding of logical structure, while Ramanujan was intuitive, claiming his formulas came to him in visions from the goddess Namagiri, with results appearing fully formed that he would then verify but rarely proved in the conventional sense. Hardy later wrote that working with Ramanujan was like discovering a strange musical instrument and learning what sounds it could produce, trying to understand the alien but beautiful logic underlying his mathematical intuition. Together they made groundbreaking discoveries in number theory, particularly in the study of partitions, which concern the different ways a number can be expressed as a sum of other numbers. Their formula for the partition function represented a major breakthrough that seemed to pull exact results from asymptotic approximations in ways that defied mathematical convention. Ramanujan also made fundamental contributions to infinite series, continued fractions, and the theory of elliptic functions, work that would later prove essential to developments in quantum physics and computer science. Despite his mathematical triumphs, Ramanujan struggled terribly with life in England. The climate was harsh for someone from tropical India, the food was completely alien to his strict vegetarian religious requirements, and World War I made obtaining suitable ingredients nearly impossible. He became increasingly isolated and depressed, his health deteriorating from malnutrition and what was likely tuberculosis, though the exact diagnosis remains debated. By 1917, he was seriously ill, spending months in various sanitariums and nursing homes, continuing to fill notebooks with mathematical discoveries even as his body wasted away. A famous anecdote from this period reveals both Ramanujan's condition and the nature of his genius. Hardy visited him in a nursing home and remarked that he had arrived in taxi number 1729, which seemed a rather dull number. Ramanujan immediately replied from his sickbed that it was actually quite interesting, being the smallest number expressible as the sum of two cubes in two different ways. 1729 equals 1 cubed plus 12 cubed, and also equals 9 cubed plus 10 cubed. This instant recognition of deep number properties in a seemingly random taxi number exemplified the mysterious pattern recognition ability that characterized all of Ramanujan's work. In 1918, Ramanujan became the first Indian elected as a Fellow of the Royal Society, one of the highest honours in British science, and the first Indian elected to Trinity College, Cambridge. These recognitions came even as his health collapsed completely, his weight dropping dramatically, his strength failing. He returned to India in 1919, hoping the familiar climate and food would restore his health, but the damage was irreversible. He continued working on mathematics until his final days, filling his notebooks with Mach theta functions and other discoveries that mathematicians would spend the next century trying to fully understand. Srinivasa Ramanujan died on April 26, 1920, at his home in Kumbakonam at age 32. His widow Janaki, then only 21 years old, was left with no pension and lived in poverty for decades until finally receiving recognition and support late in life. Ramanujan left behind 3 notebooks filled with thousands of theorems and formulas, most stated without proof, that would become a treasure trove for mathematicians throughout the 20th century. The impact of his work grew steadily after his death as mathematicians labored to prove and extend his discoveries. His Mach theta functions, written down in his final year, remained mysterious for decades until their significance was finally understood in the 2000s, revealing connections to string theory and black hole physics that Ramanujan could never have imagined. His work on partition theory connects to computer science algorithms, his infinite series appear in statistical mechanics, and his modular functions underlie modern cryptography. Perhaps most remarkably, in 1976, mathematician George Andrews discovered a lost notebook of Ramanujan's work at Trinity College Library, containing over 600 additional formulas and results that Ramanujan had written in the last year of his life. This lost notebook has generated entire fields of mathematical research, with papers still being published today proving and applying theorems Ramanujan scribbled down over a century ago while dying in India. Hardy, who spent years working with Ramanujan and decades more studying his notebooks, rated him among the greatest mathematicians in history, comparing his natural genius to that of Euler and Jacobi. Hardy devised a scale for mathematical ability where he gave himself a 25, David Hilbert a 80, and Ramanujan a 100, the highest pure mathematical talent he had ever encountered. Yet Hardy also carried guilt for the rest of his life, believing that bringing Ramanujan to England had destroyed his health, wondering if they might have collaborated for decades producing revolutionary discoveries if different choices had been made. The tragedy of Ramanujan extends beyond his early death to the question of what was lost. How many other brilliant minds in colonial India and throughout the developing world never received the education, resources, or recognition needed to develop their abilities? How much mathematical knowledge did Ramanujan take to his grave, formulas and theorems that existed in his mind but never made it onto paper because his life was cut short? His notebooks contain results that mathematicians are still working to prove and understand a century later, suggesting the depth of knowledge that died with him. Ramanujan's story challenges comfortable narratives about how genius develops and what conditions it requires. He had no formal training in advanced mathematics, no access to current mathematical journals, no colleagues to discuss ideas with during his formative years, yet he independently rediscovered results that had taken European mathematicians centuries to develop, and created entirely new mathematics that was decades ahead of his time. His claim that the goddess Namagiri revealed mathematical truths in his dreams might be understood as his intuitive unconscious mind processing patterns and relationships in ways his conscious mind could then verify, a reminder that mathematical creativity remains mysterious even to those who possess it. Today, the Ramanujan Prize recognizes young mathematicians from developing countries. The Satyendra Nath Bose National Center for Basic Sciences in India includes a Ramanujan Institute, and his birthday, December 22, is celebrated as National Mathematics Day in India. These honors, while meaningful, cannot compensate for the loss of what might have been, the discoveries never made, the years never lived. Ramanujan proved that genius can emerge anywhere, that formal credentials matter less than raw ability and determination, and that human potential remains vastly underutilized because of barriers of poverty, prejudice, and circumstance. His 32 years produced enough mathematical beauty and insight to inspire generations, leaving us to wonder what infinity might have revealed if he had lived to 50 or 60, and reminding us that somewhere in the world right now, another Ramanujan may be struggling unrecognized, waiting for the chance to show what the human mind can achieve.